grade 9s. All right, welcome back. Tangents to circles. That's today's topic. All right, so as you might recall from like the very beginning of our unit, tangents are lines that contact a circle in exactly one place, okay? And we also remember that any tangent connected to the radius forms a 90-degree angle, okay? So this is actually the first topic that I'm going to discuss in more detail, but we did briefly discuss that at the start of the unit. A couple quick notes before I discuss number one more specifically. Sorry about those notifications. We will be using Pythagorean theorem in this lesson, so if you need to brush up on that, you should. And also remember that every radius in the circle is the same length, okay? I'm actually just going to put my do not disturb on here. There we go, so nobody else bugs us. Okay, so that means that any radius, so for example, this radius would be the same length as if there was a radius here or anywhere else, okay? So that is what that means. All right, so now moving down here, any tangent connected to the radius forms a 90-degree angle. The whole bit about at the same point of tangency just means that we are talking about they're connected at that spot here, down at the bottom. So if I were to zoom in a little bit, that might make it a little bit easier to see, but this place here, that blue dot where they meet, that's called the point of tangency. So it means that if the radius and the tangent meet at the spot where the tangent hits the circle, then there's a 90-degree angle between the two of them, like this. Okay? So that's what that means. All right, so using that information, we can see that if we had a circle like we do here, and then we had a radius, and then a tangent with it, that we could make a Pythagorean theorem situation. Apparently I'm making tongue twisters for myself, like this. So we have the tangent and the radius. Okay, I highlighted them in opposite order, but that's okay. So this is the tangent, and the radius is here. Then if we connected the end of the tangent to the end of the radius, or the center of the circle, then we're going to create a right angle triangle. Now, how do I know that it's a right angle triangle? I know that because there's a 90-degree angle here, and we've made a triangle, so it must be a right angle triangle. And so then, knowing that, we can find the measure of LO, which is here, by using Pythagorean theorem. Okay, so we can do a squared plus b squared is equal to c squared. Now, we can tell that the 90-degree angle is here in the corner, and so that means that across the triangle is the longest side, which is the hypotenuse, right? So we are going to plug in 3 and 7 in the other two spots, and remember that it doesn't matter which one you plug in for which, so if you did 7 squared plus 3 squared, that's fine, okay? So then we know that c squared is equal to 58, okay, and then I'm going to square root both sides to get my c value, and when I do that, I'm going to get this really long decimal, but I'm going to round it to just 2 decimal places, okay? So there we go, 7.62, and we do have a unit, which is centimeters, so I'm going to throw that in there as well. Okay, next one. Find the measure of x. This is very similar to the previous question. Okay, we again have a right angle triangle that's been formed here between the radius and the tangent, and we then put a hypotenuse on to make a triangle. And using the Pythagorean theorem, we're going to find the length of x. Now, it may not be super apparent to you, but I will just point out that x is only like this section, okay? So maybe I'll just try and highlight it here, okay? I know it's hard for me to draw with the stylus, but I hope you guys get the idea, okay? X is just the spot from the circumference to the end of the line, not the whole thing. And you might be wondering, oh no, how do we find out just that little piece? Don't worry, I will show you, but let's start with finding the length of the whole hypotenuse, okay? So again, 4 squared plus 6 squared is going to equal c squared, okay? And I'm referring to this whole thing as c. Okay, I'm specifically not saying x for a reason. Okay. So then we know that 4 squared plus 6 squared is what we need to solve first. And we know that 4 squared is 16 and 6 squared is 36. Goodness. There we go. And that gives me c squared. Okay, so 52 is equal to c squared. And when I square root both sides, let's do it here on my calculator, I'm going to get 7.21 centimeters. Now, because we just want that little portion here, x, we need to figure out what is that, and how we can do that is remembering that this length is also a radius, right? So that's also going to be 4 centimeters. And so then x is equal to 7.21 minus 4. It's not a good 4. There we go. And that is going to be equal to 3.21 centimeters. There you go. All right. If you have any questions about that one, just message me, okay? I know that some of you may find that a little bit more challenging, but I promise it's not so bad. Okay. And last but not least, the measure of x. In this example, so remember that right here we have a right angle. Okay, that's between the radius and the tangent spot where they meet up. And we can find their value by, again, using Pythagorean theorem. We can find x's value by using Pythagorean theorem. And remember that in this case, x is one of the short sides. Okay, so we're going to get this. Okay, and that's because 12 is the hypotenuse, so it's the long side, and x and 8 are the short sides. Okay, so then when we subtract 64 from both sides, you can use your calculators. Yes, I know lots of you are thinking that in your heads. We're going to see that x squared is equal to 80, and so when I square root both sides, we're going to get a value for x, and it's going to be very close to 9. In fact, we're going to get 8.94. Okay, so that is the numerical value, and remember to add the unit. Voila! Okay, moving down. Tangents drawn from the same point, exterior to the same circle, okay, that means outside the same circle, are equal in measure. So what that means is when I have this point out here and I draw a line that's a tangent to the circle, and then I decide from that same point that we started with, drawing another tangent to the same circle, then we know that those two lines that we just drew are equal in length. Okay, that means they have the same length. And with a chord, which is shown here, they create an isosceles triangle. Okay, so that shape there is an isosceles triangle. Remember that an isosceles triangle means two sides the same length and the third is different. Okay, also a fun fact, if you were to draw these two tangents from that point to the same circle, that's it. There are no more tangents that you could draw from that specific point, okay? So that's just a fun fact if you wanted to know it. All right, so if AB and AC, remember that these symbols here, those lines, mean line AB, line segment AB, line segment AC. So we're talking about AB and I made a typo, you guys. I'm sorry. That's supposed to say AB and BC. I will correct that right now. Okay, let's zoom in and do some corrections here. Okay, there we go. So A, B, and B, C are tangents. Determine the length of, and I made the same typo, BC. Okay. So I'm saying that AB right here is 13 centimeters, and remember that another tangent from the same point to the same circle will be the same length. And so we know that the length of AB is equal to the length of BC, and since the length of AB is 13 centimeters, then that is the length of BC. There we go. It's that easy. Okay, determine the perimeter of triangle ABC. This one you may feel is a little bit more complicated when you look at it right now, but I'm going to break it down. I'm going to show you that this is really not that bad at all. Okay, so to start off, we can see that we have 3 points on the outside of the circle, C, B, and A. And from each of those 3 points, 2 lines have been drawn. Okay, you can see that. And so actually we're just drawing 6 tangents. And I'm going to use a different color highlighter to show you each one of these. Okay, so from A, we have this tangent and this tangent. And then from B, we have this tangent and this tangent. And from C, we have this tangent and this tangent. Okay, I know my highlighting is not perfect, but you understand what I mean, I hope. And we know that in each case, like both of the green lines are the same length, both of the orange lines are the same length, and both of the blue lines are the same length. And so because of that, then we know that since this line and this line are the same length, then we know that this is also 10. And then the same logic here, this line and this line are the same length, so we know this is also 3, and then this is also 5. Okay, so now we have all the pieces that make up the perimeter, which is what we want. So we can just add those up. So perimeter is equal to, all the sides added up, okay, so 3 plus 3 plus 5 plus 5 plus 10 plus 10. Okay, and then we're just going to add that all up. Okay, so we're going to get, let's see here, 20, 36. Okay, so there we go. Now, there was no unit in this question, so you can just leave it as 36. Okay, similar question, but a little bit different. And decimals this time, so yes, if you want your calculator, you can take it. I'm going to grab mine here as well, so that I can do some checking that my mental math is correct. Okay, so in this case, instead of just giving us these small line segments like I did last time, I also gave you some where it's the whole length, like this and this, okay? Now, that doesn't change much, okay? So we still have 3 points here. I'm going to do some highlighting. 1, 2, 3, where 2 tangents come from each. 1 here, 1 here, 1 here, right? Like those are each sets of 2 lines. Now, in this case, I will highlight again. I think that will be helpful for people. Okay, so I have 1 here and 1 here. Those are the same length. And then I have also here and here. Those are also the same length. And last but not least, here and here. Those are the same length, okay? Now, we are going to be able to use all the numbers that I gave you in order to figure out all of those spaces, okay, that are currently missing. So right now, we know that this yellow line is 8.2, which means that this other yellow line is also 8.2, right? So that's just from here to there. Okay, but if we know that this small section is 8.2 and this whole thing is 17.5, then we can figure out this length, right? And that's because we can subtract 8.2 from 17.5. Okay, so I'm just doing that on my calculator. And that gives me 9.3. I'm going to use a different color to make it very clear. And so then if we know that this green section is 9.3, then this green section is 9.3. So again, just going to draw it out here. Okay, and if then this green section is 9.3, but the whole section is 22.3, then we can figure out that remaining, well, I highlighted it in blue, but the remaining part of that line. Okay, so then 22.3 minus 9.3 will give us 13. Okay, and then once we have that, then we can see that this will also be 13. Now, once we have all those lengths, we can find the perimeter, right? So we can add up 8.2 plus 8.2 plus 9.3 plus 9.3 and so on to find the whole perimeter. So that is exactly what we're going to do. Okay, so perimeter. Now, the way I'm going to write this is going to look a little bit different this time, okay? I'm going to say 2 times 8.2 plus 2 times 9.3 plus, oh, this is getting messy, I'm sorry, you guys, 2 times 13. Now, the reason I'm doing that is just because it's easier to write out. I'm just saying that there are 2 sides that are 8.2 long and 2 sides that are 9.3 long and so on. But if you want to write it out the way we did the first question, of course, that's totally fine. Okay, so 8.2 times 2 is 16.4, of course. I'm just going to type these all into my calculator. 2 times 9.3, pardon me, is 18.6, and 2 times 13 is 26. So when I add those all together in my calculator, I'm going to get a nice whole number of 61. All right. The next thing we're going to learn about tangents is that 2 tangents drawn to any one circle and connected by radii. Remember that radii is that fun word for more than one radius. It's like radiuses, but we say radii because that's proper English. So 2 tangents drawn to any one circle. Okay, so here's one tangent and here's one tangent. And then connected by radii, multiple radiuses, right? 1 here and 1 here, create opposite supplementary angles, okay? So that means that the angle that is, let me zoom in a little bit, here, plus the angle that's here, together equal 180 degrees, okay? So that's what we're going to be looking at in this lesson. So the reason that we know this quickly, if you were interested, is that we can see that this shape that we just created here, like this whole thing, is a quadrilateral. Remember, that's a 4-sided shape that doesn't have to be a square or a rectangle. That we know that a whole quadrilateral has an inside degrees, interior degrees of 360. And that we also know that these two spots here are 90-degree angles because that's a tangent connected to a radius. That makes a 90-degree angle. And so if each of these are 90, then we have already used up 180 of the degrees, and that means to get to 360 we have 180 left to work with. So that means that this angle plus this angle have to equal 180 degrees. Okay, if you don't care about that explanation, it's fine, but if you do care, there you go. I won't test you on it though. And then I have another fun fact is that the line AO, which is here right down the middle, cuts both of those two angles in half. Okay, all right, so given this diagram, let's determine the measure of ABC, angle ABC. So let's be clear, we're talking about angle ABC, so we're talking about this angle right here. Okay, and we want to figure out how big that is. Now, again, let's remember that we just said that angle ABC plus its opposite angle, which is AOC, together equal 180 degrees. Now, we already know the measure of AOC. Oh, wow, guys, that was so messy. Let's try that again. Which is 140 degrees. Okay, and so if we already know that's 140 degrees, we can just plug it right in. And then we have the ability to solve this equation to find the measure of ABC, the angle. There we go. Okay, next example. Determine the measure of each angle in the image below. So this one is going to take us a couple extra steps. You're going to see that. I'm just going to zoom in a little bit here. We have an angle and then its opposite, so they're going to equal 180 degrees together, but this time they have x's in them, so we're going to have to solve for x first. So we know that this angle plus this angle equal 180. So we know that angle ABC plus angle AOC equals 180 degrees. But this time we know that ABC is x plus 20. And AOC is 4x plus 10. And together that equals 180. So now we have an equation, a type 3 algebra equation, that we can easily solve because we know how to do this. Okay, so if I have 1x and 4 more x's, then I have, whoops, there we go, 5x. And 20 plus 10 is 30. And then suddenly I can solve. Okay, so we have 5x is equal to 150. And when I solve for just one x, then I get 30. Okay, so then we know that angle I'm going to do this in a different color. Hang on one second. There we go. Okay, so angle ABC is equal to x plus 20. And we know now that x is equal to 30. So we know that it's equal to 50 degrees. And we know that angle AOC is equal to 4x plus 10. And now we know that x is 30. So that gives us a whole angle of 130 degrees. Okay, I just plugged in that x value for x once I found it, and then I could find the measure of each angle, because remember that's what the question asks us for, is how much is each angle worth. Okay, 2 more examples and then this long lesson is done. I know it's been a little while, so I'm sorry. Thank you for sticking with me. These 2 examples I would say are the most challenging out of the whole lesson, but that doesn't mean we can't do it. In fact, I think we're all up for a challenge, so let's roll with the punches here. Okay, first thing I want to talk about here with the first example is that we again have that situation where we have an angle. I should use a highlighter. And then the opposite one together make 180. Okay, so we can find out how big this angle is by saying that 180 minus 58 will be its size, which is true. Okay, so that's going to give me an angle of 122 degrees. Okay, so now that we know that this angle here, I'm going to just maybe try and do that arrow a little bit better. Zoom in. Okay, so this angle, there we go, is equal to 122 degrees. Now, if we know that, then the next thing we can do is think about our triangle knowledge, okay? So remember that this is a radius and this is a radius. How do I know that? It's because it's a line going from the center of the circle to the edge. And so if that's a radius, then this is a radius, then they are the same length, okay? And so what does that mean for us? That means we have an isosceles triangle, okay? So we have a triangle where these 2 lengths are the same, and this one is different. That also means that this angle and this angle are the same. Okay, and so that is the key to helping us figure out our length. Okay, so if that means that if this angle is worth question mark degrees, then this is also worth question mark degrees. And instead of calling it question mark in both cases, I'm going to call this x. Okay, so I would recommend you do too. It's a little bit easier. So now we have all three angles labeled something, or we know how big it is. And what do we know about triangles? All their angles add up to 180 degrees. Okay, so if those equal to 180 altogether, then we have 122 plus x is equal to 180 degrees. Okay, so I am going to subtract 122 from both sides, and that's going to give me 2x is equal to 58. And when I divide both sides by 2, we're going to see that x is equal to 29 degrees. So therefore, angle question mark is equal to 29 degrees. Okay. Whoops. All right, last example here. We're going to zoom in again for more space. Okay, perfect. So same idea here. We're going to use some isosceles triangle knowledge, and we're going to use some right angle knowledge and all that stuff to figure this out. Okay, so the first thing we're going to see here is, or the first thing that pops out to me, it's okay if you do this in a different order, is that we have a tangent and a radius. Okay, and where they meet, that is going to create a 90-degree angle. Okay, so that's a really big piece of information because that already gives us 1, 2 of the angles out of this triangle. Okay, so out of this blue triangle, I'm just going to highlight it in this teal color, we already know that we have these two angles and we can find the third using it. Okay, so we know that 59 degrees plus 90, that's the right angle, plus the last angle will equal 180 degrees. I am going to call this angle x. Okay, so plus x. So if I do 90 plus 59, then together we are going to get 149 degrees plus x is equal to 180. And when I subtract 149 from both sides, we know that x is equal to 31. Okay, so that is the size of that angle. Okay, so now once we have that, we can start talking about figuring out the question mark angle. Now, again, this is a radius and this is a radius. Okay, I know I'm not exact in my drawings ever on this iPad, but I'm trying you guys, so hopefully that makes sense. Okay, so we have a radius from the center to the edge here, a radius from the center to the edge here. That means that if this line and this line again are the same measurement. And that also means that this angle and this angle are the same measurement. Okay, that's back from our triangles unit. So then if that first corner is x degrees, then so is this. And again, that's going to help us figure out our measurement for our last angle question mark. So we are saying that x plus angle question mark is all together equal to 180. But the good news this time is that we already know what x is equal to, right? We found it just here. It's 31. So we have 31 plus angle question mark equal to 180. Okay, so we have 62 plus angle question mark equal to 180. And so when I subtract 62 from both sides, then I'm going to find out that angle question mark is equal to 118 degrees. Voila. Okay, that was a long one, you guys. Thanks for sticking around here. I hope that made sense to you. If any of these examples are confusing to you in any way, please message me. There is already a good worksheet up for this, and I will also post the assignment very soon for you guys to work on whenever you're ready. Okay, I'll talk to you soon.